Welcome to this week's NADOG online event. I hope everyone has a drink, depending on what time of day it is. Drink may be better than mine. Today is, what is today? The 16th of November, 2021. For those of you I don't know, I am Jim Schultz. I'm the leader and organizer of North American DevOps Group, also known as NADOG. We're going to kick this off, as we always do, with two quick lightning talks from our sponsors, and then we're going to jump straight into our talk. Our speaker today is Yuri with Google. He's a site reliability engineer at Google, and he's going to talk to us today about shrinking production incidents. If you have any questions at any time during this event, either during the lightning talks or during Yuri's talk, please feel free to drop them into the chat. We'll try to pause a few times too, so you can take yourselves off of mute if you want to ask that way, and then we'll leave about 10 or 15 minutes at the end for more Q&A. After the Q&A at the end, we'll stop the recording of this, and then we'll keep the line open for further discussion and some virtual socializing and networking for everyone who can stick around for just a little bit longer. As soon as I'm done talking, I'm going to drop my two links into the chat. One's to subscribe to our YouTube channel, and the other one is to join us on Slack. We'd love to see all of you in both places. So with that, let's jump into our first lightning talk from InstaCluster. Hello, Cassandra.
Hey, Jim, thank you so much for that introduction. I'm just going to go ahead and share my screen. All right, can you guys all see that? We're good?
Yep,
okay.
We got it.
All right, well, thanks again for that introduction. Thanks everyone for joining us today. So InstaCluster, we're an open source technology company that has three main platforms. We have a SaaS platform, we have consulting, and we also have 24/7, 365 support. We operate the technologies that you see here at the bottom: Cassandra, Kafka, OpenSearch, Redis, Spark, and Postgres. We're full life cycle, so we're going to be with you guys from the very start to the very finish. We're 100% open source, meaning we have no licensing fees, no vendor lock-in, and no proprietary features, which typically translates to saving companies thousands of dollars per year. We're operations first, meaning we didn't necessarily write Cassandra, but we are absolutely the biggest operators of these technologies with over 120 million node hours of experience collectively. All of our builds are certified and tested, and we also fill gaps from the open source ecosystem. So for example, if there is a gap that needs to be filled, we would either write that ourselves or we would reach out and collaborate with the open source community and also give back. People come to us for a number of reasons, but the typical challenges that we see from our customers is operating open source technology is hard. The technologies themselves are rather complex, and finding the people to operate these technologies are also hard because it's very competitive. Scaling is hard as well. Once you scale, it can happen rather quickly. So if you're scaling quickly, you need to be able to manage that. So that's one thing that we're able to step in and do. Again, hiring and retention is hard. The market is incredibly competitive. I believe the average Kafka engineer is about $130,000 per year, which can be very expensive. So our solutions, we eliminate all these problems with our SaaS platform. Again, you're able to self-provision and spin up a cluster within minutes. We mitigate these problems with our 24/7, 365 support. So if something were to go sideways at 3 o'clock in the morning, we have someone available for you. All you have to do is give us a call, and our experts are available for you whenever you need them. We're also a single vendor with no lock-in, meaning, so for example, if you're operating Cassandra and Kafka or more than one technology, you don't need more than one vendor because we're able to operate all of these within one platform. And then a little bit about us. So InstaCluster was founded in 2013 in Canberra, Australia. We have over 200 employees now. We have a global presence in over 4 offices. I'm actually located here in the Phoenix one, but our US headquarters is in Redwood City, California. As I've mentioned before, we have a 24/7 tech ops and DevOps teams in Australia and the US, and we have over 500 customers with over 120 million node hours of experience. We've got some big names here that have jumped on as our clientele, for example, FedEx, T-Mobile, IBM, Sonos, Dream11, Kohl's. And if you guys have any questions, I will certainly put my information in the chat box, and you can add me on LinkedIn.
Cool, thank you, Cassandra. And yeah, if you wouldn't mind, drop your contact info, then any other links that you'd like to share with the group as well regarding InstaCluster would be awesome.
All right, thanks guys.
All right, thank you, Cassandra. Thank you, InstaCluster. Next up is Matt with trendmicro. Hello, Matt.
How's it going?
The floor is yours.
We did practice this sharing screen thing, so give me one sec. So my name is Matt Chapman. Thank you for having me. I'm a technical advisor at trendmicro. I handle very large enterprise accounts in Georgia and Florida and other parts of the Southeast region as needed. I would say that I am pretty much in the right place with DevOps conversations because a lot of what I work on right now is the cloudone infrastructure that we have. If you haven't heard about trendmicro, we've been around for over 30 years. We're one of the top proprietors of security structure, if you will, for AWS, Azure, Google Cloud, and all the Fortune 500. So if you haven't used us before, I would really encourage you to take a look at our stuff from a DevOps perspective and a cloud perspective. So let me just show you a couple of things here. So we have, if you look in the center, this is like it's a 5-minute thing, so I want to make it quick. So we have this thing in the middle. We have this big blue cloud, if you will, and we have, as you can see, we handle AWS, Google Cloud, Azure, VMware. We can approach things from a hybrid perspective from our workload security. We don't have to just do cloud. If you have stuff that's actually running local, we can actually protect it there as well. But this kind of sums up the pieces and parts that we have and the workloads that we cover. So we're really involved with the DevOps cycle. We have the workloads we can protect, like EC2 instances or images inside of containers. We can look at open source as far as what the actual pieces and parts of your code are to make sure that they're not introducing any vulnerabilities. And we can also protect with application security some serverless stuff as well. And at the same time, give you all the governance. And if you're excited about the right side with the Snyk logo down there, that's because we partnered with them for the last part of our current Cloud One platform. So looking at it in this way, it's a single sign-on, one console, common user and cloud enrollment for accounts. It is a common procurement and billing. You can actually use Marketplace for a lot of it if you want to. The API is very extensive, so you can do a lot of things with the API if you want to code some things into how it performs. And looking at individual pieces here, you can see that workload security, we're going to do workload and container on the host, so we can actually do IPS protection of the container itself that runs on the workload, but also do things like file integrity monitoring and log inspection and things like that that'll help you with some of those checkboxes you need for, say, PII, PCI. Container security goes a little further when we're actually doing admission control policies and runtime protection and looking at the image that we're scanning and saying, is this image actually ready for production? Is Jenkins going to say yes after we say it's good to go? So those are pieces and parts we can do from a container perspective. So we actually won't let you deploy malware into the system. We see that a lot, by the way, with people that just go to, say, docker.org and grab some image that they think is all ready to go and they don't have to work on it anymore. And then they deploy malware into their instances and don't even know it. Application security covers serverless functions, APIs, and applications. With a very small 2 lines of code, we can actually set up protection of your applications in the cloud so that you're able to make sure that you're not introducing any SQL injection or anything like that. And then if you're storing anything on S3 or Blob, so we can also do file scanning for any uploads you may have to your S3 buckets. And then if you've heard of Conformity, we bought them a little while ago. I think it's about 2 years now. And Conformity is, think of like your posture management for your cloud infrastructure. So you're in AWS, you're in Azure, you're in Google Cloud, but you want to see if you're actually working alongside, they say, the AWS well-architected framework or NIST or whatever you want to look at. We run a bot that looks at everything and says, okay, did you even know you had some S3 buckets that are public, right? And we can actually make those determinations and give you basically a scorecard, and it's in real time. So as you're making those changes and seeing those things, it actually fixes it as it goes. But the other good part is if you're really new to the stuff or you have someone on your team that is, it'll actually, when you press resolve, take you to a how-to of how to do it either by command line or GUI, depending on where the error in that posture was, right? So if you haven't, like an example, again, if you have S3 bucket that's open to public, it'll show you the steps to do it from AWS command line or from the GUI to go fix that. And then it'll run again and you're protected. Pardon the sniffle there. On the open source piece, we've partnered with, like I said, with Snyk, so we can actually look at vulnerabilities in your code repositories. A good example just to show how that works is as Snyk is running, and again, this is all from one console for us, no jump offs. The vulnerabilities will be maybe because a library file that you're using for your list, right, is one revision back, and that one revision back throws in a vulnerability CVE. Well, we see that and we'll say, well, you get up to version 2, that goes away, and it keeps you in a nice clean code format as you're moving forward. And the last but not least is the network security, which we have now in AWS. And the big part about this is, if you're familiar with Tipping Point, we bought them about 4 years ago, I think it is about now. And we have implemented the Tipping Point product in the AWS cloud. So if you want to protect your VPCs or anything going back and forth from your VPCs to, say, even your segment back at the data center, if you have one of those going on, like a transit gateway, we're able to actually see all of that traffic and apply IPS rules against it. So even if you're not doing the host layer stuff over like on workload, we can set up policies to protect you at the VPC layer as well. So I like to think of it like this big piece of cloud here is a whole big onion that we have several layers that we're providing protection across. So as you shift left from being on in a data center, we're actually, and you're moving into the cloud, we have you covered there. And if you have some of the stuff still hanging in data center, we can cover you with the same console. So that's what I had. And if you would please, if you have this is a QR code, but if you scan that, that'll show you a setup for our booth that we have at AWS reInvent. So I'm happy to see you guys there. I'll be there virtually.
Well, thank you very much, Matt. And if you have a link for that too, you can just drop into the chat in case people can't pull their phones out fast enough. And your contact info or LinkedIn link, whatever you want to share too, would be awesome.
Absolutely. Sure thing. Thank you so much.
All right. Thank you, Matt. And thank you again to trendmicro for sponsoring and supporting the community here today. All right, let's jump into our featured talk here today. Yuri is, I guess it's a second time speaker at NADOG, spoke earlier this year as well. So thank you very much for coming back, Yuri, and sharing with the group. Yuri today is going to talk to us about shrinking your production incidents. And he's an SRE at Google. So if you have any questions at all, again, please drop them into the chat during the talk, or Yuri's agreed to pause a few times to see if anyone wants to come off of mute to ask questions, and then we'll have time for more Q&A at the end, as we always do as well. So with all that, Yuri, it is all yours.
All right, thank you so much for having me. Really appreciate it, and thanks for the intro. So today's talk is about service outages, how to learn from them, and then how do you use what you learn from the outages to set your engineering priorities. And then I'm going to talk a little bit about how to approach specific engineering tasks that target weaknesses in the reliability of your services. So I'm going to be talking about all of this within the context of site reliability engineering, or SRE. So just to make sure that kind of we're on the same page, I'm going to do just a very fast refresher on what SRE is. This is something that started at Google because we basically found that traditional operation models, ops, doesn't really scale. So this is the result of turning operations into a software scalability problem. One of its main high-level benefits is that it creates an alignment of incentives across business units, and it also allows for kind of both high development velocity as well as consistent reliability of your services. Some of the fundamental concepts that we use in practice are error budgets and SLOs, which are service level objectives, or essentially targets for how reliable your service needs to be to meet the needs of its users. We work with what we call blameless postmortems, and I'll talk a little bit about that in some more detail in just a little bit. Now, obviously, like this skips over a lot of detail. We've literally published books on this topic. If you go to google.com/SRE, you can find kind of great detail about all this stuff. But I just wanted to kind of put some of the basic concepts out there. So what does this all mean for production incidents? Well, we know that we want to keep our users happy, right? And if our users are not happy, they'll go somewhere else. And so when we think about the products that we build, it's easy to just think about the features that we advertise, the features that we sell or charge for. But this talk is really about what we consider to be one of the top two most important features of any product, which is reliability, with security being the other one. Without that feature, none of the other features matter at all, right? Because you won't have any users left to actually enjoy them. And one of the primary ways by which our users experience the reliability of our service, or rather at times the lack thereof, is through service disruptions or outages, right? And the kinds of systems that we're now building and running, right? Large, complex, constantly changing systems. It's really not a question of if we're going to have an outage. It's just a question of how often is that, do we have outages? And then how much impact do we have on our users, right? So let's look at how a service outage actually impacts user happiness, so we can define some vocabulary around how we think about outages, right? In general, while the outage is ongoing, user happiness falls. And then while our service is stable, user happiness rises. So let's break this down into phases, right? The first phase is this idea where basically the outage begins, and then the alert actually fires, right? We get a notification that something is wrong, and we kind of go into the triage mode, right? And our users are obviously less happy during this point. The time from when the problem actually starts happening and when we receive the alert notifying us about it is called the time to detect. How long did we know? How long did it take us for us to know about the outage, right? Sometimes that time to detect is how long does it take for our alert to fire? Sometimes it's how long does it take for users to complain, right? But that's the first phase, is that time to detect, right? Once we are aware of the outage, we start working on it. We perform our triage, our mitigation, rollback, whatever the case may be. And at some point we have fixed it for our users. We call this the mitigation point, right? Where our service starts to recover, user happiness starts to rise. The time from when we know about the issue until we've mitigated it is called time. We call that time to mitigate. And then finally, at some point, the outage will happen again, right? And this period between our last outage starting and our next outage starting is what we call the time between failures. So these kind of the three main things that we want to think about when we talk about the impact of an outage on user happiness. All right. So what did this outage actually cost us, right? There's like direct costs, like revenue. There may be user happiness costs, right? Reputation costs, bad press. So how much would we pay if we could to avoid this outage, right? Well, when we think about doing retrospectives or postmortems on our outage, we're actually kind of turn that question the other way, which is we have already paid the cost of this outage by incurring it, right? How do we now extract value from our payment, right? What can we learn from this outage that'll make future outages less costly, right? Another way to think about it is your outages are unintentional investments, okay? You have unintentionally chosen to invest some small percentage of your revenue, hopefully, in discovering that you have a reliability weakness in your service. What returns can you now extract from that investment? And this is what postmortems are really for, right? So our primary goals are to make sure that our incident is documented, that we understand the root causes, and that we both plan and execute the work to improve service reliability, which means we need to not only figure out how to avoid the same failure, but also how to address the entire class of failures that this outage represents. Okay. Generally speaking, we should write postmortem after any significant outages or what we might call a near miss. So incidents that don't actually affect users, but only because we got lucky somewhere. And finally, it's really important to recognize that writing postmortems is not punishment, right? In engineering, we do things because we think they're a good idea, right? Postmortems give us an opportunity to identify things we should work on, to identify tasks, because we can prove that they're a good idea based on their impact to the last outage, right? And the only way this can work, the linchpin that holds all of this together, is this culture of blamelessness, right? So let's take an example. Let's say I'm on call. I get an alert for an outage, and it looks like I do some initial debugging. Looks like servers are running out of memory, so I restart them. Okay. This actually causes a cascading failure, because now all that traffic that was going to the out-of-memory servers is now being sent to the healthy servers. Those servers become overrun and crash, and essentially I take down the entire service. Why did I do that? Why did I restart all of those servers at once? Well, in the postmortem, I'm going to say, well, this is standard practice. We've done this before. It's kind of fixed things in the past. So I thought it was a good idea. All right. In this case, however, the standard practice was actually because the wrong decision, right? And so our postmortem can identify the need for tooling to automate this process and ensure that there's always sufficient capacity available. It can also, prove that we should actually work on cleaning up our memory leaks so that we don't have these kinds of memory caused outages in the future, right? So in the culture of blamelessness, there's a basic assumption that the person taking actions or the people or the team are all acting in good faith, right? They're doing the best job that they can with the knowledge and the tools that they have. And you can identify the causes of things without implicating people personally, right? Generally, that translates to not actually having names in the postmortem, right? So you would say the on-call engineer restarted the server rather than Yuri restarted the server, or it's commit number 3423 rather than Yuri's commit, right? That kind of stuff. You get the same information out of it, but it's not about putting the spotlight on the engineer who was involved, right? And ultimately, you're trying to fix the system here, right? You're not trying to fix people. We think, again, think back to the kind of the introduction to SRE, we think about operations as an engineering problem, right? When things go wrong, we want to look for flaws in the system that allowed those things to go wrong or that allowed an outsized impact of those things to take place. Now, obviously, some of the fixes may still involve people, right? A lack of incident response training is a people problem, but it's really a systemic problem that needs to be solved by people training people, okay? But the point here is, if we actually want to learn everything we can from an incident, we need to be able to get to the bottom of things. And you can't do that if people are scared to tell the truth, right? Everyone makes mistakes. That's not the problem. The problem is when the systems allow mistakes to be damaging or more damaging than they need to be. Once we have yeah, go ahead.
I'm sorry, there is a quick question in the chat here from Christian. How does SRE manage partial failures as for highly available services?
Yeah, that's a great question. But basically, the idea of defining an event-based service level indicator, measuring, for example, the percentage of requests that are completed over a specific amount of time and setting a target for those is how we actually go about measuring the reliability of our service. So, for example, we set a target that says, instead of a 99% uptime target, our reliability target would be that 99% of requests have to complete successfully over a rolling 28-day window. Then if we kind of have a running error budget based on that, and if we start to, our error rate increases, you kind of start to see how much of our error budget we have left, and based on the increase in error rate, based on how dangerous that is to the SLO, we'll trigger a pager alert or something like that. And so when you have a service that is a complex distributed load down service, right? The only way you can really reliably measure the reliability of it is by looking at user interactions and how successful they are over a period of time. I'm again glossing over a lot of detail just because the ideas of service level indicators or SLIs, service level objectives or SLOs, and an error budgets, that's a talk in itself. And I'm not happy to talk about it, but this is not that talk, and I don't want to take too much time away from the kind of the primary message here.
Well, so there's one more in here. Let me, if you don't mind, I'll ask this one, then let you get back to your deck here. But should we focus on resiliency of the system, such as reduced MTTR as an alternative in case we cannot fix the system through postmortem?
Yeah, so that's a good question. So I don't want to give anyone the illusion that a culture and a practice of postmortems is going to quote unquote fix the system, right? The objective of a postmortem is to generally identify what can we do better for this type of incident to detect it faster, triage it better, mitigate it faster, or prevent it from happening at all, right? A postmortem for a particular incident is really not the place to raise issues that didn't contribute to this specific incident. I think that's one temptation you should stay away from, right? Any system will always have any number of issues that you think need to be fixed, right? Any system is going to have technical debt in it. When you're writing a postmortem for a specific incident, you don't want to be distracted with trying to tackle that technical debt unless it's specifically contributed to this particular incident. So that's the first part of this. Part two of my answer is we have actually recently found, and we've published an external report on it. I should dig it up and put a link in the chat here, that we no longer think of MTTR, or mean time to resolution, as it's essentially a useful metric. There's way too much variability in what causes an incident, how long does it take to detect and triage and mitigate it. Even over time, even at scale, even when we look at a critical, kind of a critical mass of incidents, the data is just not statistically useful. And so we're no longer we in a Google SRE are no longer using MTTR as a meaningful metric. You could still absolutely evaluate the TTR of a given incident and evaluate, what contributed to how long did it take us to resolve it, and fix some of those things, right? Identify action items and address them. But that's not the same thing as looking at MTTR of a given system over time.
Cool. Thank you, Yuri. And yeah, keep the questions coming. Thank you, Rao, for that one.
Yeah, great questions. All right, so go back to our idea here, right? The point that I want to get to is when we think about how do we improve our ability to detect, mitigate, and make our incidents less frequent, right? We want to look for patterns in our postmortems to identify where we can focus our engineering effort. Obviously, this list is not exhaustive, but these are some specific engineering tasks that we have found to have a strong impact on improving or really reducing each of these three phases, right? If you want to improve time to detect, it's all about getting better at defining and measuring failure. Time to mitigate is mostly about preparing the responders in their environment, okay? And then time between failures is really mostly about engineering discipline. So let's dive in here and talk about each of those things like that. We're going to talk about kind of why each of these tasks is important and how to actually approach implementation of these. Okay. So let's first talk about shrinking time to detect. You can imagine that you're having an outage and your air budget you start burning air budget, and it's burning so fast that if you ignore this issue, it will actually consume all of your remaining air budget, and you will in fact be out of SLO and possibly even violate your external SLA if such a thing exists. The time to detect is from when this actually starts happening to when a person who can actually fix the issue is alerted. Okay. Now remember, if you're on call, you can't begin to triage a problem until you know about it. Okay. So if you look at your postmortems and you see that there's a lot of impact to users in this phase, this is where we need to tighten things up. Okay. So this is actually going back to the previous question about MTTR, right? Your alerts are driven by SLIs, service level indicators. So you want to have good indicators that give you a good representation of the end user experience. One way by which you can make this happen is to measure user experience as close to the user as possible. If you can, that means taking your measurements from the client side, right? If you're measuring latency or availability, then latency and availability at the client is what matters to your users. You actually want to include like the flaky network between your service and the client. If you know that your users need a sub 500 millisecond response time, you may actually, if you measure the client, you may find out that your service actually needs to deliver only 100 milliseconds of latency at the load balance. This will mean that you are likely to catch problems that aren't your fault, but just because it's not your fault doesn't mean you can't do anything about it. Now, sometimes, and maybe most of the time, you actually can't do client-side instrumentation, and that's okay. You should be aware that that means your view of your user's experience has less precision. Another way to tune up your SLIs is to actually verify them against external sources. A good SLI will be basically high or good when users are satisfied with your service in real life, and will go down when your users are frustrated. Okay, so for example, if your SLIs are showing you that you're having an outage, but users aren't complaining, you might be measuring the wrong thing, right? So you actually want to talk to your users to find out exactly what bothers them and what doesn't, and then adjust or pick the metrics you use for SLIs based on that. Just like you need to iterate with your SLIs, you should also refine your SLOs, or your service level objectives, the targets for the SLIs, okay? You need to align them with your users' expectations. It's not usually obvious what your users need, so you need to adjust your SLO targets over time as you learn more. It's particularly important that you don't set your SLOs too tightly, right? Do your users actually need 4 nines, or are they going to be just as happy with 2 nines? Every additional 9, so going from like 99% is called 2 nines, to 3 nines, which is 99.9%, to 4 nines, which is 99.99%. That roughly translates to about 10 times the cost, due to things like engineering, infrastructure, staffing, things like that. Running a service at 4 nines is not cheap, so you really want to make sure that you need it before you commit the business to supporting it. And finally, your alerts need to be consistently useful. You want the alerts to only fire when real users are being impacted. Now, this goes back to the quality of your SLIs and SLOs, but it's important to see how good quality SLIs and SLOs directly translate to alerts that engineers learn to trust. And along the same lines, you need the alerts to be both sensitive and actionable, right? It's hard to get both at the same time. But it basically comes down to the period of time that the alert averages over before it fires. If you alert too quickly, then you might be kind of paging on blips, false positives, essentially. If you alert too slowly, then you're losing time you could be using to mitigate. And it can take time to find the right balance. But generally, if you focus on these 3 areas, your SLIs, what are you measuring? Your SLOs, what are your targets for those measures? And your alerts, which is how quickly do you fire alerts, that's how you can really make improvements in time to detect. Okay. The next area you want to focus on is time to repair, right? Time to detect is all about technical tasks. Time to repair is mostly about the people, policies, training, and stress management, right? Even if you have a great alert that happens very quickly and tells you that there's a problem, it's not very useful if then everyone panics, right? My opinion is that this is actually the most important section to focus on. You're always going to have outages. You can have monitoring be as good as possible to tell you that you're having outages. You can automate, really good, fast solutions to a lot of problems, but you can't always do that. You can't do that for everything, right? Ultimately, we hire engineers because of their intelligence, their creativity, and they are actually the best resources we have for fixing all the problems that aren't automatable. They're also the slowest way to fix a problem, but they're the last most capable line of defense, so we got to invest in them. Okay. One reminder before I get into the section. An incident responder's first duty is to protect the user, which means during an outage, you want to focus on mitigating the effects on users, not on finding and fixing all the contributing factors. So some good responses: temporary failover, version rollback, emergency capacity, right? Data responses: debug the code, fix the code, check it in, run a build, do a deployment, right? It takes way too long. And it's actually really risky. How do you know that the thing you're pushing isn't just going to cause a different problem? That's the kind of stuff you want to do later when the service is not actively burning. And that's really the difference between mitigation and really, really fixing. So what can you do to improve your time to mitigate? Well, first, you got to train the on-callers, got to train the responders. You need good emergency procedures, and you want to define and test them so that everyone who is involved in incident response is calm and productive during an outage. Generally, you want procedures that provide enough structure and protocol so that you have an organized response, but you also want to be open and flexible so people can do some stuff ad hoc. And this isn't just for the people who are actually on call, who are carrying the pager. This is for everyone who could participate in incident response, development, product management, executives. Don't train people just once. This kind of training can actually get rusty pretty quickly if people aren't doing this all the time. For example, we at Google, we run weekly failure drills. These could be practical drills where we actually break stuff, Depending on the test, it could be a real system, it could be an internal replica. But we also do theoretical drills, what's called a wheel of misfortune, where we just kind of talk through how to handle a particular situation, right? You don't even have to do a complex drill. You can just be like, we're getting user reports, they can't log in. What do you do? Right? And then the person has to like figure out, okay, what do I look at first? Where's the documentation? Where's my playbook or my run book? Where's my monitoring? Where's my logging, right? And if they don't have all that stuff easily available, they don't know exactly what to do, you're identifying opportunities for improvement just from a very simple exercise like that. Okay. The objective is to get folks experienced with critical thinking communication, knowing when to escalate and doing all of this at a time of stress. The second thing, and I've already alluded to it, is you have to write run books or playbooks, okay? This is the first thing the on-caller is going to see when the alert fires, and you need to have one for every alert that can fire. Generally speaking, you're looking to write down things like special response procedures, links to dashboards, search queries for debugging logs, right? Everything that someone who is handling the alert might want to know. Now, it's going to be impossible to know every possible cause and fix before you even make an alert, but the runbook should absolutely give the responder a clue as to kind of how to start the investigation and where to go for help. All right. Now, something that happens a lot is someone writes a runbook and then like no one else can actually understand it or use it. When you write one of these, and you think you're just writing it for yourself, you want to keep it simple. Write a version of it for write it for a version of yourself that just got back from vacation. And you have no idea what you're doing anymore, right? You'll thank yourself later. And this is actually a good opportunity for a failure drill. Send an alert to a volunteer and see if they can actually follow the runbook. So anything they had to do that wasn't in the runbook, add it in, right? It's actually really easy to forget kind of these basic steps in the stress of an outage. Next, you want to focus on the on-call responders themselves. Pager fatigue is a real problem. Being on call is hard. And if you want to keep your on-callers, you want to make their happiness a priority. Over time, we have found that most folks can only handle about 2 incidents per shift before they feel overloaded. This obviously varies between teams and companies, but it's a good starting point to aim for. You want to automate the routine operational tasks as much as possible. Generally, we call this eliminating toil. One classic example of this is release management, right? How much of the release process should be automated so that you don't have to babysit it? If the load is too high for your operational team, you actually want to shed some of it. Ask the developer folks to carry the pager, or maybe loosen the SLO until the service is stable enough. And then obviously the final point is dashboards and logging, right? Measure everything is kind of our motto, right? You know, record every response code, every contention event, every queue length, and then visualize these metrics on task-specific dashboards to allow on-callers to get the data they need to make their decisions. Obviously, keeping metrics forever costs a good bit of storage, so set retention limits, right? So that just only the metrics you actually use for long-term decisions are kept for a long time. Okay. So those are the kind of things you can focus on to improve your time to mitigate, to shrink your time to mitigate. All right, we've mitigated it. Great. Our users are regaining confidence in our service, and we want to expand this phase as long as we can. Okay. We know that the most common trigger of outages are code and configuration changes. So to maximize time between failures, we should just stop doing that, right? Well, that might work for a bit. And sometimes it actually is a good idea. Like, you know, if you have one weekend in a year where you make all your revenue, but generally you don't want to and can't stop changes, right? There's always features to push. You got to fix bugs, new infrastructure, whatever. But changes can be made safer, right? And let me go back to what I just said a second ago. You don't necessarily want this phase to last as long as possible, right? Because if you go too long without an outage, your on-callers get out of practice. And then when you finally do have an outage, and you will, it's going to be much worse than it would have been otherwise. Okay. And also, we've seen that when we prioritize time between failures too highly, we kind of err on the side of stability. We slow our releases down to a crawl, and that's bad for lots of reasons, like lost velocity, poor response time to market forces, all that sort of thing. In general, we really encourage folks to think about shrinking time to detect and time to repair, rather than focusing on time between failures. Nevertheless, there are things you can do, and this is talking about engineering, engineering discipline, right? Maximizing time between failures largely comes down to discipline and a recognition that anything that depends on a manual process is slow and error prone, right? So we generally want to think about improving the practices that go into what our developers do, right? Doing code reviews, kind of focusing on code quality, making sure that we have requirements around how much of our code has to be covered by testing. All of that stuff really does make a difference. Next up is CI/CD, so it's continuous integration, continuous delivery. This is basically how you deploy changes with confidence that they won't blow up in production, right? Having CI/CD will mean that your issues are fewer and then they're smaller. You want to have automated tests as part of that pipeline, and actually rerun them often to catch regressions. At Google, for example, we run every automated test on every code, on every change request. And then the change doesn't actually get committed until all tests pass, right? And you want continuous delivery to actually get new code out as often as possible so that each release is smaller, which means that smaller things can go wrong, right? It's also much easier to figure out what goes wrong when each release only changes a few things, okay? One thing that's really important about continuous delivery is this idea of gradual rollouts. So you want to be able to kind of do canary analysis, right? Discover problems and roll them back before all the users are affected, right? Roll out to just a few users, see how it goes, roll out a little more, right? Kind of flatten out that sadness slope. And you want to have the ability to, if you do roll out some bad code, to roll it back really easily, okay? Some other things that go into maximize our time between failures would be the architecture itself, right? You want to have robust architecture, with things like redundancy, avoiding single points of failure, graceful degradation, right? And reevaluating architectural decisions in the course of your postmortems, okay? And then the final thing you want to think about is this idea of chaos engineering or resilience testing, okay? This is, we generally tend to use resilience engineering or resilience testing. But this is basically about finding problems under controlled conditions so that you don't find them in uncontrolled conditions, right? I've already talked about testing for training people, but you can also test your systems this way too. And, obviously you want to automate this, right? Now, write a test to break something in production, you expect that nothing happens. And generally speaking, you want to keep your service within SLO by basically consistently breaking things and making sure your architecture can recover easily. So to summarize, basically the entire idea of this talk is the information you need to determine what to do to improve your ability to detect and mitigate incidents and to increase the time between incidents is in the postmortems, right? Your postmortems should guide you, and that's how you make your, they are an existing investment, and now it's just a matter of extracting value from them. All right, thank you so much, and I'd love to take any further questions that folks might have.
Thank you very much, Yuri. We do have a few questions in the chat, so let me read those to you, but also to let everyone else know if you have questions as well. Just drop them into the chat, or we'll pause to see if anybody wants to come out from mute and ask a question that way as well. We'd love to hear your voice. So the first one is from Rao here. Is there a way to measure and report on whether releases are automated? Perspectives may vary between the delivery teams.
Yeah, that's a good question. I'm a little biased in that what we basically do at Google, and I realize this is not really an option for everyone, is that we basically make it such that changes to production can only be done via automation. There are some break glass stuff you can do, but you can't do a release to production manually, at least in any way that I'm aware of. Maybe there is, but I've never seen anyone actually do it. But one which you measure is you make sure that that's the only way that it can be done. You essentially remove the ability for folks to do releases to production without you relying on the release pipeline. I think you might get some pushback, people saying, but what if we need to do an emergency patch, et cetera, et cetera, et cetera. I mean, the simple answer is if you're doing that, you're already not doing the right thing, right? Mitigate. I've already talked about the difference between mitigating and fixing. If there's an incident in flight, you should be focused on mitigating. Very rarely does that mean you need to be pushing out a new version of your software. Most of the time, if your software is at fault, you need to be rolling it back, not pushing it out. So that's the first part. Is my sort of opinion is you should only be doing that via automation anyway. You basically just prevent people from doing it any other way. And then obviously that'll kind of report the data. In terms of how you might go about reporting on it or measuring it for cases where people can do things manually, it really depends on like, what does your platform look like? What does a release mean? Is it a new container image, for example, in which case you could see kind of how the image was built and deployed, or is it some other way by running software? But generally you're looking at kind of creating or keeping some kind of an audit trail for how releases were done. And that's always a good idea anyway.
Well, thank you, Yuri. The next one, are Google's SRE tools all built in-house? And what tools does Google use for runbooks?
Yeah, great question. And I'm proud and sad to report that, yes, we build everything from scratch. We build the entire stack is built in-house. So the platform that we run on, all of the instrumentation, monitoring, and observability is built in-house. All of the automation is built in-house. Now, like we're just a giant company that we can afford to have teams that focus on building all of the tooling. So, release management is a product that we build for internal use, which means it has a development team. It has its own SRE team. Same thing for monitoring, for logging. Like these are each products that are built for internal use that have their own product management, development, SRE. Probably not realistic for folks that are not operating at the scale that we are. So I would say in this one area, you probably should not follow our lead. Most folks do not need to build their own time series databases from scratch.
Unless maybe
and for runbooks, it's honestly one of two things. It's either Google Docs, but most of the time we use our internal, basically what other people would use like as a wiki or something like that. We just put it in there. So it's not necessarily, because it's just a document that just kind of tells you what to do in specific cases. It doesn't actually matter what tools you use. The important thing is that the alerts point to that thing, and then the thing is kept up to date. Those are the important things to worry about. We integrate them with our source code management system, so we can track like freshness and things like that. So we can tell you when the runbook was last updated, and we actually have automation in place that'll like basically bug the owner if the thing hasn't been updated or reviewed in some amount of time. So that applies not just to runbooks specifically, but to all documentation on our platform. And so that is one forcing function by which we make sure that things are at least looked at on a semi-regular basis.
And this next one, I assume, Yuri, is the same response. Follow up to the last question is, what about tools for measuring automation? And what tools does Google use for automating testing?
Yeah, so most of the automated testing that I've seen is essentially unit tests, where that would be kind of part of we just use mostly internal unit test framework, but they're very similar to what you might use externally as well. And then those are just, the tests are included in the CI/CD pipeline. So anytime you commit, anytime you make a commit, the thing runs, it runs all the tests. If the test pass, then you actually have the ability to essentially do our equivalent of a merge. Again, we've written our source code and all that from scratch as well. So there's some idiosyncrasies there, but if you think of the Git model, yeah, on every commit we run unit tests, and then only when all the tests pass does it get merged. But the direct answer to your question is it's all stuff that we wrote ourselves.
Okay, the next one from Ryan. Can we use chaos engineering to train our incident responders as well as test our system's automated response to failures?
Yeah, great question. In my experience, I always tell people that chaos engineering is like the graduate level class. And if you don't have a practice around this today, you should start with the theoretical exercises. You could follow our practice for what's called the wheel of misfortune. There are other folks that have sort of similar approaches, but generally, when I've worked with external folks who have done this, they have found that they were much less prepared for actual chaos engineering than they thought, because they realized they didn't have good alerts in place. Their run books weren't up to date. The run books didn't have the information they needed. They didn't have good incident management practices in place. They didn't know how to escalate. The on-callers, basically didn't know what to do and ended up just like paging the rest of the team. And you can get all of that discovered with a very simple theoretical exercise without really doing chaos engineering. Once you do a few of those, once you kind of really shake out the bugs out of your incident response process and your incident response practices, and you feel like you're in a pretty good place with that stuff, then you start doing like actual breakage testing. The emphasis there really more is on the system itself, but you can absolutely see like, if we break this thing, does it trigger an alert? How do people respond to the alert? All that kind of thing. But I would very much encourage you to think about using theoretical exercises to train and test people and processes, and then chaos engineering to test the system itself.
Cool. Thank you for that one, Ryan. Next one from Christian. Does Viceroy support alerting?
Yeah, so Viceroy is, I'm not sure if it's really like well publicized, but it is our internal monitoring system. Or it's really the UI and dashboards that live on top of what we call Monarch, which is the actual monitoring and time series system. Viceroy does, let's see. The short answer to the question is Viceroy itself is not where you go to like configure and set up the alerts. Viceroy is really the dashboarding tool, and it's like the UI that people use to interact with Monarch. It's being replaced with a new generation of those tools. The underlying technology is not really being replaced, but in order, everything we do is done as code. So monitoring is configured and alerts are configured using the same code framework. That Viceroy will show you what alerts you have configured, and it'll show you thresholds and things like that. But you don't use Viceroy to configure the alerts. And again, this is only relevant for anyone who like cares about how Google does its internal stuff. It's not anything that people ever see.
All right, and the last one here that's in the chat. I'm thinking out loud here, but is there any merit to tracking outages caused by the rollback?
Yeah, so you should absolutely track causes of outages. This is what was the one. Well, let me even back up a step. Outages could be caused by lots of different things. Separately, they can be triggered by lots of different things. What triggers an outage and what causes an outage aren't really the same thing a lot of the time, right? The cause of an outage is, and I'll give you an example that I was dealing with literally yesterday. It had to do with, BGP prefixes and limits on one end. One end had had a lower limit for how big the prefix could be, and everything was fine for a very long time. Suddenly, the other end decided to change the size of the prefix. A valid change that they needed to make for whatever reason, but the client wasn't configured for that size, and they suddenly started basically couldn't make connections anymore. The cause of the outage was that the client's prefix limit was set too low, right? But that had been the case for literally years. The outage wasn't triggered until the server changed the size of the prefix, right? So this is an example of where an outage where the cause and the trigger weren't actually the same thing, right? My point in telling you that story is when you're talking about tracking causes of outages, I would say that what I have found by reading lots and lots of postmortems is that it's going to be very difficult to have a lot of the times outages are caused by a combination of things that aren't a single cause. It's going to be this combination of things that caused it versus things that triggered it. But generally speaking, if you're going to be tracking things over time, you're going to be tracking, it's not necessarily so much about tracking the causes. We found more value in tracking the action items. what can we do to better detect, mitigate, and prevent this kind of incident in the future? And that's where you get sort of value over time, because you start to look at where are we having to make more improvements? Are we really focusing most of our efforts on detection? Are we focusing most of our efforts on triage? That gives you, I think, some value in terms of the priority decisions you can make. My experience personally is that analyzing causes is difficult, because a lot of the postmortems will just have like the cause section of the postmortem will basically be a narrative story, and it's hard to use that. It's like unstructured data that's kind of difficult to use in aggregate. Whereas the action items enumerated in the postmortem are structured data that's much easier to use in aggregate.
Well, thank you, Yuri. Hold on real quick here. We're
Keep 'em
actually
coming.
at the top of our hour here. I'm going to keep reading our questions here. We have a few more in here, but I want to end the recording. If you're watching on YouTube, come attend the next NADOG event live if you want to continue this conversation with us in person, or in person virtually, I guess, in real time and virtually. So we'll see you on at the next event. Thanks for tuning in on YouTube.